Welcome back, students, to your first video for business analytics programming. And in this video, in the slides, we basically just want to go over lists and NumPy arrays, right? Like I said before, there are three different data containers that mimic basically the behavior of vectors or arrays from R. But one is native, it's called lists, and you'll see what the deficiencies in it. And we will obviously work with NumPy arrays. And from there, we're going to work on something else called series, which is from the pandas library. Okay, and those are basically the, mostly we'll be working with NumPy array and PD and the series container, type of containers. So from here is where we left off, basically from our introduction. And this is, again, I'm using the Spyder. I'll be using Spyder when I do the class. But you could feel free, if you're familiar with a different Python IDE, feel free to use whatever one you want. It's perfectly fine. For any newbies, I'm using Spyder, so if you want to follow along with Spyder with me, that's fine as well. Again, just like I said before, Spyder tends to be used for data science, right? Because you can open up the data objects directly from it, as long as they're not too big, and depending on your memory size, and view the table in Excel sheet mode, like an Excel sheet. So I'll show you guys that. So when you open up Spyder, all right, this is what you see. I have it right here. Let me actually zoom in a little bit, all right? And for any of my ABI students, you'll notice there's some similarities to R. Right off the bat, you have 3 windows here instead of 4, and you have a script file right here. Your script file is right here, and it opens up automatically called NumPy. Okay, and down here is just like we had the console in RStudio. We have the console down here in Spyder, and this is where the native Python code goes to get processed. So if I type in 2 plus 2, right, like it serves like a TI-85, I get my answer 4. Directly right there, it gives me input and output. I want to always save my Python files. Notice up here is temp.py. You want to always keep your lab separate and any codes you're messing around with, any practice sets separate as different Python scripts. Remember, it's smaller is simpler and better. So how do we save this? Just like you would save any kind of Word document, PowerPoint, Excel sheet file. Go up there to File, do Save As, and I will save it under my class. Create a directory just for this class. I created one called BAP Summer 2020, and I'm going to go ahead and save the name to Lab. Well, should I call this Lab 1? It's not technically Lab 1. I'll call it Intro. I'll say intro.py. And I'll save it. Make sure it has the extension .py, and it's saved. From now on going forward, any file with the .py extension will be a Python script. Will be a Python script for you guys. We talked about this, the console. Boom. Let's actually write in the, well, I call the lab 1 here. All right, it's fine, whatever. Name's a name. So here, let's go and process the code. Let's talk about how this works. So I'm going to go in here and directly type in 2 plus 2 like I did before. All right, now here, unfortunately, right, in RStudio, for my ABI students, if you remember, anywhere where I had my cursor, if I wanted to process this line, I would just do Command Enter. I mean, if you're in a Mac, it would be Command Enter. For PCs, it's a Control Enter. But when you do that here, it doesn't work, unfortunately. I'm on Spyder 3 point something. There's a new 4.0 version. Maybe it'll be different, but you have to basically highlight the whole line and then process it. Right? You see how I did that? I highlighted the whole line, and then if you're on a Mac, do Command Enter, and it sends the code directly into the console here from the script, just like in R. and it processes it. And if you're on a PC, you do Control Enter after you highlight it. And this allows you to do it for one line and multiple lines. One lines and multiple lines. There is a print function as well that pretty much does the same thing. Right? Same thing. Now, we just jump into it. Let us import two packages. We won't use them yet, but we're going to. All right? Might as well talk about it now anyway. I'll put them up here. Any kind of imports you always do on the top of your program. The first one is going to be import NumPy as NP, import pandas as PD. Okay, now what's going on here? Okay. Just process them. I will explain. Let me explain them right now, actually. So, pandas and NumPy are libraries, right? Again, if we're talking about my ABI students, think of your R packages. Remember those packages we would install, third-party packages? That's what NumPy and pandas are basically are. We're importing those libraries into our memory, so now we have access to both the NumPy functions and the pandas functions. Pandas is built on top of NumPy. NumPy is basically R for Python, if you want to think about it that way. NumPy is R for Python, the vector logics, and pandas is the data frames souped up on steroids. Okay. Now, so import is that command that calls in those libraries. What is this as p, as np, as pd nonsense? These are basically, the way it works here in pandas is that every time I want to call a function from any one of these packages, I have to call the package name and then to type in dot and then the function I want. So numpy dot this or pandas dot that. What this as construct allows us to do in Python, it allows us to assign some sort of shortened variable to represent each one of these packages, so we don't have to keep typing in numpy or pandas. We can just type in np dot something or pd dot something, and you'll see this in action. NP and PD, as the as is a keyword, that's why it's in blue. But that NP and PD is a variable name. It could be anything you want. It could be A and B, apple, orange, does not matter. I just use NP and PD because that tends to be the syntax variable that most people use, but you have total freedom there, guys. Total freedom. All right, so from here, let's run a couple of these lines. Now let's run x equals 4 5 and 6. Highlight the line, command enter, look what happened. When I process that, just like in RStudio, boom, on the top right, the data container, a new data container was created. Now, if you remember in R, for anybody that took R, the C parentheses created a vector for you. Well, here, it's a little bit simpler actually. This is one of the few things about Python that are actually simpler than R. You just use brackets and comma. It actually looks like, the syntax actually looks like what you would use to create a vector or an array. And so here you are, gives you the data container name, X. The type it is list. This is important. This is a list type of data container. The size and the actual values, 4, 5, 6. All right. Now, firstly, if I were to, when this thing is processed, just like in RStudio, when I process line 15, down here in the console, it just ran the line and that's it. No results were given. That's because, again, when you have a single equals, ladies and gentlemen, if you remember from ABI, what happens if you have a single equals? You're either creating or transforming an existing data container. You're either creating a new data container or transforming an existing data container. In this case, we don't have an X, so it creates a new data container. When that happens, the results go up here. Even though the line is processed here, the results go up here. There is no output. There's no output because you're behind the scenes, you're allocating memory to these variables. All right, I mean to these values, So that's number one. Number two, if I want to see the values of X, I simply just type in X down here, and it'll give me the now you notice the inputs there and the output as well. Or even in my script file, I could just type in X by itself, highlight it, and the same result, and I can see the values there, right? So I would have to call the data container itself without any single equals, and then I'll get the output I want. And again, you can use print as well. Now, I'm going to create another type of data container, A. And now I'm going to just say A equals 5. All right, so now A shows up there, the line was processed here, and it shows up there. Notice the difference. A is not a list. A is an integer. It's a type integer, size 1, value 5. I mean, in Spyder, they even give you different colors. This is yellow, that's purple. What's going on here? What's going on here is Python is like more of a real programming language like C, C++, and Java, in the sense that it makes a differentiation between data types and the data containers. So it makes a differentiation between data types and data containers. Now, for my students that weren't my ABI students, you don't understand what the big deal here is. The big deal here is in R, everything is a vector. Everything is a data container in itself. Not so with Python. Individual values in Python are considered what you call explicitly, they're called data types versus data containers. And the data containers hold different data types. So 4, 5, and 6 would be an integer. Okay, 4, 5, and 6 would be an integer. But X itself is the data container. And A is a data type as well. That's not in a data container. It's a data type. So individual values are not data containers. Right? This is different than in R. And here, I will show you what I am talking about. Here, if I do A of 0, you get an error. Right? It's saying, hey, what are you doing? This is an integer. Why are you using this bracket logic? Right? And where in R, you wouldn't get this error. In Python, it's much stricter, which some of you guys actually might like a lot more, because that flexibility kind of tends to, even though I love it for some people that come from a more orthodox programming background, that flexibility confuses people. I had a C programmer once, and he was like, Python's horrible. This is horrible, right? Because you have to rethink the way, I'm sorry, R. He's like, R is horrible because you have to rethink the way R did things. So that's the deal with Python, basically. I mean, here's your first difference between Python and R. Now, for those of you new to programming, what is this bracket? What is the bracket nonsense I did? Well, for A0 of 0, it's not going to work. It's not going to work because, again, A is not a data container. But X is a data container. If I do X bracket 0, what value do I get? I get the first value in that data container, which is 4. If I do X bracket 1, I will get the second value, which is 5. And if I did X of 2, I would get the third value, which is 6. So those brackets next to a data container are basically this, all right? And I like using this in both my R and Python classes. Data containers, especially when we're talking about a vector or array, are like a bookshelf. Are like a bookshelf. If you want to think about it, take the bookshelf and push it to your left side. Just tip it over to your left side so that it goes across. But those data containers are bookshelves. Okay? Depending on the size of that list, that is how many shelves you have in that book container. Within each shelf go data types or values. So in this case, the book is A. The book is A. Oh, basically, the book is either 4, 5, or 6, or any other kind of value. The shelf itself is X. It's a data container. It holds the books or data for you. That's how lists work. Now, when we just type in X, it gives us the whole bookshelf. All the shelves plus their values. Okay? All the shelves plus their values, the whole bookshelf. But with the data container, if you bring in the brackets logic, open close bracket, whenever you see it now, an open and close bracket immediately after a data container, what you're doing now is you're saying, think about it like a window. What you're now saying is, don't give me the whole bookshelf back. Don't show me the whole bookshelf and all the values in the bookshelf. Show me a particular value in the shelf. Show me a particular value in the shelf. So that's what we did in line 19. In 19, we're saying, go to the bookshelf X and grab me the value that is on the first shelf. That is on the first shelf, and give me that value back. And that's that's why when we processed line 19, we got the value 4 back. We got the value about 4 back. And that's why when we processed line 20, we got the value 5, because that's going to, 1 is now going to the second shelf and grabbing the value back, showing it to you, right? It's not altering the bookshelf. It's simply looking at the value and telling you what value it's there, right, for you to use and know and understand or whatever. Now, here's another major difference between R and Python. In R, your first value position is 1. In Python, your first value position is 0. Just like in Java, just like in C, just like in C++. Here, Python actually follows the logic from other programming languages. Where R, it actually starts with 1. Why? Because R is written by human beings for human beings. They're told 0 nonsense. It gets weird dealing with it, but you'll get used to it. For someone like me that goes between R and Python, I make these mistakes all the time between 0 and 1. So it's just something you're going to have to get used to it. Some of you guys that come from, again, a non-R programming background, you're like, yeah, sure, whatever. For those of you that are my ABI students, this is going to get some used to. You just have to remember, okay, with Python, it always starts with 0, not 1. Okay. I also want to show you, some of you guys like using, I believe, Jupyter. And in Jupyter, you have that cell structure, We have that in Spyder too, if you want. I don't tend to use it. I like going line by line or highlighting, but I'll show you to you anyway. What is this? Basically, you can create as many what we call cells as you want, and you can process each cell separately. All right, let me show you this. So let's make this one particular cell. And the way you create the cells, by the way, is it's very subtle. It's very subtle. Use the hashtag, and then you do %%. Hashtag %%, and that in Spyder. This is, by the way, not a Python thing. This is a Spyder thing. All right, this is a Spyder thing, guys. So if I do, let me create the first one. Always separate your imports separately from the code. So I'll create a few cells. Here's one cell. Sorry. Here's another cell. So I create a few cells. and this will be the last cell. So I created basically 3 cells. This is one cell of code, another cell of code, and obviously anything after this is a third cell of code. All right. So what does this mean? When my cursor is in each particular cell, you notice it goes kind of yeller. I don't know if you can see it in the video, but if you're doing this live, you'll see it. Right. So when my cursor is there, now what happens is anywhere my cursor is in this cell where it's yellow, anywhere, it doesn't matter. If I do Command Enter, it processes all the lines from that cell. 12 and 13 are processed. Same way here, no matter where my cursor is in this cell, right? Let's say it's in line 16. It processes line 15, 16, 17. If it's anywhere here, like here, I'm going to put it on line 22. Oh, let me get rid of this error. By the way, if you want to comment out code, it's just a hash pound. For those of you guys taking any notes, it's just the pound. The pound just gives you comments. So you can write any kind of comments you want. I know some of you guys, as you go along with the video, you guys like putting your own notes, which is fantastic. Just use the pound to do it. So here, again, I put it on line 22. I press Command Enter, or again, if you're on a PC, Control Enter. Boom. It processes all the lines. This is the same logic in Jupyter, where you have different cells of code and you can process those lines of code. You can do either or. It does not matter, right? If you wanted to get rid of this, you simply just go up here, guys, and delete it. It's gone. This is now 2 cells. This is now just one giant cell. And now it's gone. Right? Now it's gone. I don't have, now it goes back to line by line highlighting. So again, it's up to you guys how you guys want to work Spyder. I don't tend to use that, but that's me. There's no right or wrong answer of how you want to do this. Okay, so that's just a cool little way for you to also process code in Spyder, especially if you have different chunks of code that you're messing around with. All right, so now let's get into lists. Let's now get into lists, and there are some similarities, I guess. Not really. So R really doesn't have something like lists, even though a list is native to Python. The R vectors and NumPy arrays, they're more similar to NumPy arrays, and you'll see that. Lists is something that's more into itself. This is something that comes in handy when you're doing web programming. And in general, in Python, we use lists all the time without even thinking about it. But for our purposes, for analytics purposes, we obviously rely much more on NumPy and series than anything else. All right, so let's jump to it. All right, so we already have a vector called, vector. We have a list called x, right, which has the values 4, 5, and 6. Let's create another one called Black Panther, right? And obviously you know this. This is probably when Endgame came out. If you notice by my variables, right? If you haven't seen Endgame yet, what the hell are you doing with your life? So I'm gonna type in Black Panther, Wakanda Forever Money. Now, slide prompt. I'm gonna copy and paste this, and you're gonna find copying and pasting from my slides is a nightmare. It's a nightmare. I have to figure out how to have my slides so that they do it properly. You see, it comes out wrong with the wrong quotes. And so I have to go back and fix the quote. Put spaces in here where it shouldn't be. It's just a mess. But for you guys, if you're my ABI student and you want more practice, type in the code. If you're new to programming, type in the code. If you know programming, you can just a lot of times eyeball and cheat like I do, because you can learn straight from the slides instead of actually doing it. Okay, so here we go. I have X. I'm going to highlight this line, process it, and now I have Black Panther. And look up there, you now have Black Panther, then X. Both are 3, both have the values there. Notice the difference, though. Black Panther has what we call strings or alphanumerics. These are strings, alphanumerics. These are strings, and alphanumerics are basically words, things that have letters in them, okay? They're not numbers that you can like add and subtract and do any kind of measures and ratios or whatever. Right? It doesn't matter. Lists hold it. No problem. All right, fine. Sounds good. Well, now look, I create this thing called Avengers. Another list called Avengers. All right, anybody want to guess what happens here? Will I get an error? Or will it happen? No error. Up here, again, it has Avengers as a list, size 3. It has the first value as a string, and the other two values are numbers. List is very flexible. Like I said before, it comes in very handy when you're doing web development in Python. Right? It's very, very flexible. And just like before, right, I can do x of 0, gives me the value. I do Black Panther 1, Avengers 2. Black Panther 1 gives me obviously the second value of Black Panther, which is forever. And I do Avengers 2. Which gives me the last value of Avengers, 12. All right. Now, let's just get this out of the way. If I did Avengers 3, you get an error. See that? Index error, list index out of range. You're calling an index on a data container that is not of that size. Because 3 is you're saying, hey, give me the fourth value of Avengers. There is no fourth value of Avengers. So that's an error. Okay? Now, look at this. Again, look at Avengers. It has Iron Man, 5, and 12. Lists does not care. Lists does not care. Lists can have strings. It can have numbers. Any combination. It can have something we call floats. Floats are with are numbers with decimal places. We'll see that a little bit later when we deal with NumPys. And it doesn't care because lists are what we call objects, and it stores them as objects. What's an object? An object is a type of data type in programming languages that basically can be of any size. They can be of any size. Because they could be of any size, they're extremely flexible. And that's why lists can store any kind of data type in it, right? In any combination. It does not need to be one type of data type or another. It can be any type of data type in any combination. It doesn't matter. It gives you tremendous flexibility. With that tremendous flexibility comes massive amount of memory use and a lot of processing power. So it means it's slow. It's slow. You don't notice that because we're doing something simple. But look, when we start messing around with the labs and we start processing all this stuff, I try to keep, and for BAP, I try to keep the data sets as small as possible, just like we did with ABI. But still, I mean, the data we tend to use in BAP tends to be a little more real than in ABI, and you'll feel it. You'll feel it, especially some of the processing power. I mean, some of the functionality we use it's just processing hog. Some of the stuff we do, some of the algorithms we run. Some of the algorithms that we run, it's going to take a lot of time. So this is one strike against list. Even though the flexibility is amazing, it's about speed and efficiency. So here's a job interview question for you. What's the difference between list and NumPy? Give me one of the differences between list and NumPy. NumPy's it's so much faster than lists when you use it. NumPys are so much faster than lists when you use them because NumPy arrays don't allow this flexibility. Just like in R. It doesn't allow that flexibility. And because of that, they're stored more efficiently, unlike lists, and because of that, they're faster. But you do lose that flexibility that you do have with lists right here. All right? Cool. Okay, excellent. Now we can mess around with changing the values. And again, for any of my R students, this is just like we used to do in RStudio. This is just like we used to do in RStudio. If I want to change the first value, sorry, overwrote that. Let's do it down here. I want to change the second value of Avengers, which is the number 5, and I want to change it to Captain America. Okay, highlight this, you run it, no errors. No errors. Over here, you can see the value has changed. Let me just type it down here. You can process it down here. Avenger. And looky, down here. You have Iron Man, Captain America, and the number 12. It does not matter. I just replaced a number with a string. It doesn't matter with lists. Very flexible. Very flexible. All right. And just like in R and every other programming language, we have our for loops. We have our for loops. So the for loop, just like in R, if you guys remember, we can loop through a vector or a list, in this case a list. The syntax is now going to be different. The syntax is going to be different. And this is now something that's unique to Python. Python does not use those curly little braces like other programming languages, including R. Python uses something what we call tabbing, right? It uses tabs to construct the for loops and the if-else statements. The reason for this is the people that develop Python, they wanted the codes to be cleaner and more uniform across whoever develops it. And the tabbing was a way to force the aesthetics of the way the code is placed to be the same. Some people love it, some people don't. It's a matter of preference. I personally don't care. Just whatever makes me money at the end of the day, right? So here is, let's say we're looping through the Avengers list. Oops. For X in Avengers. Now, firstly, notice that, and then we're going to do print X. All right. Yeah, excellent. All right. Now notice, first of all, when you're typing in Spyder, automatically when you put that colon in there for the 4x, it tabs it for you. Like line 34 was tabbed for me. Excellent. Done. Now, for and in are in blue. You notice that? Why? They are keywords for Python. So this is basically telling you, hey, we have a for loop coming up. All right. The X and the Avengers part, that is something we place in the for loop. To the right of the in, just like in R, we're going to place the vector or list that we want to iterate through. To the left of the in is the variable of our choosing that's going to take on the value for each value in Avengers for each iteration. So, firstly, what's the size of Avengers? Avengers is the size 3. That's 3 elements. Therefore, this for loop is going to run 3 times. Each time it runs, X will become a different value in Avengers going from left to right. So or basically the first value all the way to the last value. So the first value of Avengers is Iron Man. In the first loop, X will be Iron Man. In the second loop, X will become Captain America. And lastly, in the last loop, X will become the value 12. And if you highlight this, and guys, when you run this now, you have to basically highlight the whole for loop or put the for loop in its own cell, right? It all has to be run in one shot. And now you can do Command or Control Enter. And you'll notice down here, the code was sent down here into my console and it was processed. The first item value printed out was Iron Man, then Captain America, and then 12. So that's basically how for loops work. Let's see if I have another example here. Okay. So before we jump into this example right here, for if else is, I want to show you guys another example. Let us use the, by the way, check this out. Notice that my X, because I use because I used X as a variable for Avengers, it overwrote my original X list. See that here? See, x is now became a variable, and the last variable in x, the last variable in Avengers basically became the value for x. All right, so from here, the next option we have is, I want to show you something else. So let me rerun this right there. So x becomes a list again. Let me do another for loop. This time I'll do for I in x. Right now x is a list, guys. 3, 4, 5, 6 up here. See, because I reran line 15. And again, I'm going to do print I. Okay. Notice the colon. You need the colon after the for loop. And now we have 4, 5, 6. Now, what am I trying to show you here? What I'm trying to show you here is anything that's tabbed after that for loop is going to be run. So if I have print I in the for loop, for every iteration. So let's say I have print I, and let's say I do print I plus 2. Now what are my values going to be? Okay, well, now what are my values going to be? It's basically going to be, for every iteration now, the first value of I is going to be 4, the second one's going to be 5, the third one's going to be 6. For every iteration, though, it's now not going to run just one line, it's going to run 2 lines. It's going to run 37 and 38. So if I run this now again, you'll see that I had 4, 6, 5, 7, 6, 8. Why? Because for the first loop, I was 4. And then we came here and we printed I, which was 4. And then we printed I plus 2, which is, again, 4 plus 2 is 6. That's why the first two values are 4 and 6. And then I became the value 5. And then we printed I, which was 5. And then we printed I plus 5, which is 7. And then I became 6. And then we printed I, again, which is 6. And then I plus 2, which is 8. You see? This happened because everything that's tabbed after that colon, immediately after that colon, will be run for every iteration of the loop. If I had something like this, highlighted these 3, and then I ran it, you'll notice I get the value 4, 5, 6, then 8. Why that happened? Because now the only thing running for every iteration of the loop is line 37. So when I is 4, it prints 4. When I is 5, it prints 5. When I is 6, it prints 6. And then it finally exits the for loop and then goes and runs line 38. And it runs I plus 2. And the last value of I at that moment was 6. So 6 plus 2 is 8. And that's why we get 4, 5, 6, 8. So that's the whole point of tabs and for loops for those guys, and the refresher for for loops for my ABI students. So that's basically how tabs work. That's basically what I mean by it's a tab. It's a tab-based structure for the for loops. And because of the tab-based structure for the for loops, it's also a tab-based structure with the colons for our if-else statements. Now, remember we have our Black Panther list, Wakanda Forever Money, right there. It's in line 24 of my code right there. Let me scroll up a little bit. Let me save my code also. And now let's play with the if-else. Now remember, from if-else's, again, my ABI students, if-else's, if statements is how we make decisions in our code. Is basically how our code makes decisions and makes choices. Let me go ahead and copy. Let me copy this one too. I'm doing it in bits because I don't know how it's going to come out. Well, let me do that. Okay, looks like I have to copy it all in one shot. Hopefully it's not too ugly. Oh yeah, it's ugly. So let me just copy. Let's see if we can copy just one line. Ah, stop it. Stop it. Oh, I'm going to do the hard way. Oh, I think I just have to. I have to just type it, guys. All right. I'll just type it. If, quote, Killmonger in Black Panther. Then we do print yes. Oh, did I spell that right? Killmonger, yes. Print yes. All right. Now for my ABI students, you'll notice this in keyword. In R, we had percent in percent. In Python, it's just in. It's just the in, and we can do it. All right, so what's happening here? We're basically checking to see is Killmonger, the value Killmonger, in the list Black Panther? And if it is, print yes, and that's it, right? Notice again, I have the colon here, and notice again, it's tabbed in, right? It's tabbed in because it's directly related to that if. And notice I get no output. Why do I get no output? Because Killmonger is not in Black Panther. So this created a false. Because this was false, nothing tabbed after it, be it 1 line or 1,000 lines, was executed. Right? Was executed. For this line to be executed, remember, just like in R, this statement must be true. This statement must be true. So let's go here now and do Wakanda. Let's do the same thing. Let's copy this now, this if statement. And now let's do Wakanda. Now we know Wakanda, we can see from line 24 up there, that Wakanda is indeed in Black Panther. So now when we run this, what do you see? You see a yes. See that? A yes. So if Wakanda is in Black Panther, you print yes, and we got the output yes, because now Wakanda is indeed, the value Wakanda is in Black Panther, right? Is in Black Panther, is in the list Black Panther. And because it's in the list Black Panther, you print out the value yes. This is a fantastic way to check for values in a list, right? Just like in R, just like in R. And now I will introduce you to the concept of how the if-else is done in Python. And again, you have the colon and you have the tabs. You have the colon and the tabs working hand in hand. So I already have Killmonger. I'll just add the else. So now this is an if-else. Notice again, the if part has the colon, and all the commands you want to execute if this is true will be tabbed in after it. Again, be it 1 line, 1,000 lines. And here, the else, again, it has a colon, and everything you want it to run afterwards is tabbed in. So for example, let me just add something else here. Let me do print, tab, do print, chocolate. Just run some random statement. And now if I go run this whole thing, you see that both no and chocolate were printed out. Why? Because Killmonger is not in Black Panther. This create statement was false. Because this was false, this line 47 is completely skipped, as it happened up here. But this time we have an else. So what happens is, if this is not run, then automatically this will be run, else will be run. Likewise, if this was true, let's say hypothetically we had Wakanda. Right, and if we ran this, then you'll see yes was run, and because this was true, and if line 53 was executed, then lines 55, 56 were not executed. All right, so that's basically how the if-else works. This should be a refresher from R, but the syntax is different now. You guys see the syntax? The syntax is different. We call those conditional statements, guys. Okay, now here's some nifty little functions from the world of lists that we can use. They come in handy all the time. And obviously NumPy has its own versions of these as well. It has its own versions of these as well. So if I want the length of a list, right, in this case, I can see clearly it's 3. But for those of you guys that aren't on Spyder, right, the length function, if we type in length, len, Black Panther, or any list, this will give you the value 3, right, the length. And notice the length is actually the true length. So even though we have the indexes as 0, 1, 2, the length is simply just telling you this, the number of values in that data container Black Panther, or the number of shelves. There's 3 values, so therefore the size of the length of that list is 3. There is also the cool nifty little append function for lists is built in. And this is again for my ABI students, you should recognize this kind of syntax. This is, in the world of programming, is called a method or a function. Well, it's a function, but it's a particular kind of function because it's a function that's being called from the data container itself, meaning that this is a function pre-built into these list data containers. And the way you want to call any of these functions that are pre-built into the data containers, right, are you just simply type the name of the data container, do dot, and then the function name. So in this case, the function name I'm calling is append. So that's the syntax with the whole dot function, any function name, dot function name, dot function name. These are functions that are pre-built into data container. We'll see the syntax, we'll see the syntax when we use the PD and NP variables as well. When we want to call functions from those packages, we do literally NP dot, and then the function name, and PD dot, and the function name. This will become a little more intuitive as we work with Python, So here, I'm going to do copy. All right. And again, fix the code because it's supposed to be immediately dot, immediately the function name. All right, I'll highlight this. I run it. And now Black Panther has, up here, if I scroll to the side, you'll see it. It now has 4 values, and you'll see Vibranium was appended to the end of it. How nifty and cool is that? All right, so what append does, it does exactly what it says it does. It just keeps adding values to the end of it, to the end of the container. Now, let's say hypothetically, I wanted to add Vibranium, not to the end, but I wanted it in the, let's say, the second position, right? So likewise, we have the append function, but here we also have the insert function, So we already have Vibranium here. Let me add something besides Vibranium. I can't remember exactly anything from the movie. Let's see, what else should we add? There's a Vibranium. And so instead of Vibranium, I will add, I can't remember anything. Let's see, I will add the, it doesn't matter. Shield, I'll just add the word shield. All right, so now I'm going to use dot insert, and now insert, unlike append, has 2 parameters, not 1. Has 2 parameters, not 1. The first parameter is basically telling you where the value is going. Here I'm saying put it in the 1 position. Now what's the 1 position again in Python, guys? It's the second position, the second value. So shield is going in the second value. Now here, just so you recall, Black Panther right now looks like this, Wakanda Forever Money, right? Right now, Wakanda Forever Money and Vibranium. Right now, whatever is in the second position is the value forever. Forever is in the second position. So basically what's going to happen is shield will be placed in the second position, and everything else gets shifted to the side. So before it was Wakanda Forever Money Vibranium. Now Wakanda, shield was put in the second position, and anything that was there before just got shifted to the end. So that's why it's now Wakanda, shield, forever, money, and vibranium. Again, nifty little functions, right? We won't use it that much, but you will use it more towards the end of the semester. All right, so that's basically those nifty little functions. And also, we can remove a value, right? We have the dot remove. If I want to get rid of forever, I simply do Black Panther dot remove. Or what did I remove in there? Forever, okay. Type in Black Panther, and now it's Wakanda, shield, money, and vibranium. Wakanda, shield, for money, and vibranium. So it just went and found wherever forever was, and simply got rid of it. Simply got rid of it. Right, and that's how remove works. Again, another nifty, very convenient little functions here. There's also another function called pop. And what the pop does is that it simply just removes whatever. So pop, you can give it an index. It works the same way as remove. But if you don't give it any kind of index, so pop basically works on numbers, right? You have to put the number position in. Let me show you. Again, dot. So if I do pop 1, right now shield is in the 1 value or the second value. So if I do pop 1, right, you'll notice it gives me an output. It says, okay, shield, that's shield. And when I type in Black Panther here now, so pop actually gives you an output, by the way. It actually gives you an output. It doesn't simply just remove it. But what ends up happening is it gives you the value, but it actually removes it as well. So it does two things. See, remove just removes the value. Pop will actually give you an output. Remember, when we did remove, there was no output. Pop will give you an output. It'll give you that value, and at the same time, it will remove it from from the actual existing data container. And if you don't have any kind of parameter there, if you don't have any kind of parameter, it will automatically just remove whatever's in the last value. So if I do this, it gives me vibranium because that was the last value. And as you can see now, the only thing that's left in Black Panther is Wakanda and money. Pop is cool because it's used to create what we call stack type of data containers or stack kind of functions where you're adding certain kind of processes you want to do and then you want to remove them, et cetera, et cetera. So, I mean, this is where pop comes from. Again, we have this in Java as well. I believe there's functionality around it in C and C++ so you can create this. So this is why we have these functionalities. They're old school legacy functionalities. All right. Now, if you want to use keyword to, again, you can, we have something called a DEL keyword to also remove indexes. It's slightly different than the way we use remove and pop. DEL, you type DEL. DEL is now not a specific method for that data container. DEL is a different kind of function that's built in Python for all type of data containers. So this is why the syntax is now different. It's not a method that's pre-built into the lists. It's actually a universal function that we can also use to do deletes. And that's why the syntax is different. So let me do Black Panther forever money. Let me just have that. Let me rerun that line. Line 24. So it has 3 values again. And now let me use the DEL function to delete. So if I do DEL, remember Black Panther right now is it's Wakanda forever and money. So if I do DEL Black Panther bracket 0, what am I deleting, guys? The first value. All right, and so now if I type in Black Panther here, guys, you notice it's like forever and money. So basically it works the same way as remove. It works the same way as remove. But unlike remove, right, if I were to do DEL Black Panther, no brackets, but just DEL Black Panther. Remember, if we just call Black Panther, if we call any kind of list or any kind of data container without the square brackets, we're calling the whole bookshelf. We're calling the whole data container. So if I say delete to the whole bookshelf, look what just happened in the top right window. Is Black Panther anywhere to be seen? Nope. If I type in Black Panther here, notice I get an error. It says Black Panther is not defined. DEL deletes not only elements within a data container, it deletes the whole data container. And it comes in handy when you're dealing with a lot of data that you're summarizing and that you're transforming. And it's a lot of data, so you want to make sure your memory doesn't take up too much information. So you delete a lot of stuff. So you'll delete a lot of stuff. Okay, the clear method. It works the same way. It's a so the clear method is basically like a bomb to clear all the values out. So let me rerun Black Panther again. So again, I have 3 values for Black Panther. And if I do Black Panther dot clear, first of all, again, Wakanda Forever money. But now if I do dot clear, by the way, notice when I did the dot, the nifty little functions popped up. See? Nice, all these little functions. And it's cool. It's a cool feature of Spyder as well. Clear, parentheses. And I ran it, and let me get rid of this. That's why I do have the little triangle thing here, because that delete thing is, I commented it out because it thought for some reason it didn't exist. So notice what happened with Black Panther. Black Panther still exists up there, but notice the size is 0, and notice the values in there. There's nothing there. If I type in Black Panther here, the output I don't get an error. I do get an output. It's just an empty list. So a data container exists. There's just no values in it, guys. The data container, you can have a data container. You can have a bookshelf that has no shelves. And that's what Black Panther is right now, because all the values have been cleared from it. All the values have been cleared from it. Okay? Here now I show you another way to create a list. And you use the keyword called, I'm sorry, you use a constructor called list, parentheses, to make it, right? So let's do that here, just to show you what's going on, syntax. And this will play a role later on in the semester when we work with something called tuples. Tuples. Now this right here, ladies and gentlemen, but we will use the list function for other objects to convert into a list. But this right here, the parenthesis Wakanda, comma forever, comma money, is what we call a tuple. Okay, what's what we call a tuple. And this is something that is Python specific. Tuples are basically the same thing as lists, except actually they're not the same thing as lists. They're similar to lists, but this is actually another job interview question. One of the popular Python job interview questions they always give to entry levels are, what's the difference between a tuple and a list? Right, so what's the difference between a tuple and a list? A tuple is stored much more efficiently and it's much faster. Okay, let me show you what I'm talking about. But I'm going to call this T for tuple. Oh, God. So much easier. All right. I'm going to go ahead and run this line of code. This is a tuple. what the hell is a tuple? If I type in T down here, you'll notice I get, in parentheses, I have Wakanda Forever and money. Now, just like in a list, I can do T of 0, get the value Wakanda. I can do T of 1, get the value for forever. And I can do T of 2 and get the value of money, right? So what's the difference? Tuples are much faster and they're stored more efficiently. Cool. Why? How? Because if I try to change the value of tuple, say money to uh, widow, notice what you got. Type error. Tuple object does not support item assignment. That, ladies and gentlemen, is the big difference between a tuple and a list. You cannot update the values of a tuple. No, 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 no. You have to rewrite the whole the tuple. The individual elements cannot be changed like they can be in a list. Biggest difference between a tuple and a list. That is why here, now, let me copy and paste this. The list command allows us to convert a tuple and other items, by the way. You'll see us use list again, that function, to convert it into a list. So when I do this, Black Panther took the values from the tuple T and it made a list out of it. And now those values are changeable. Okay? So that's just one of the things the list, that's basically what the list function does. That's basically what the list function does. And so here I introduce you to the concept of tuples, which again is a Python concept. And you have to understand the reason why they created tuples was because of the fact lists were so friggin' slow. All right? And so this concept of tuples is pervasive throughout Python. And it actually allows a lot of flexibility when you're running different functions of Python. And we'll see this. We'll see this later in the semester. All right? So that's basically what a tuple is. And that's why we have the double parentheses. That's why we end up having the double parentheses. All right, now, here we're now going to get into why we need the NumPy arrays versus the lists. All right, so let's create these lists. We have these lists 1, 2, 3, and 4, 5, 6. And my ABI students, I expect a certain answer from you guys. So if A is 1, 2, 3, and B is, I believe, 4, 5, 6, excellent. 4, 5, 6, right? C equals A plus B. What is C? All right, my ABI students, what's the answer? At this point, my ABI students should give me the answer 5, 7, 9. My ABI students, you are wrong. The answer is 1, 2, 3, 4, 5, 6. The A plus B, right, when you're adding two lists together, and holistically, it just appends it. The plus just appends it. So it's just 1, 2, 3, 4, 5, 6. What? That's right. List doesn't have the concept of vector mathematics. Enter the other big reason for NumPy array, probably even a bigger reason for NumPy array. This is why NumPy array basically ripped off R and took its features into Python. Okay? Enter NumPy array. Now look, so we'll jump into NumPy array. Now look, individually we could do the additions, right? It's not a problem. So let's say if hypothetically I had, instead of C equals A plus B, let's say I did C equals A of 0 plus B of 0. You'll notice the answer is 5. Right? That's fine. 1 plus, it allows you to do the individual math. It just doesn't do the vectorized mathematics for you. So that's why you can get the 5, right, and all these other values. That's fine. But it just doesn't allow you to do the vector mathematics, if you guys remember from R. That we're going to use NumPy array for. And now we are ready to enter the world of NumPy. All right, enter the NumPy. What is NumPy? It's a fundamental library used for scientific computing, right? With Python. It's an open source library. Somebody else designed it, some really smart individual. Powerful n-dimensional array objects. It's not just a single array. You can have a 2x2 dimension, 2x3, 3x3, 4x4, etc., etc. Advanced array slicing, taking subsets. It contains different libraries with numerical routines, basic linear algebra functions, Fourier transforms. This is for optimization if you're doing it for any PhDs. Sophisticated random number capabilities. NumPy can be extended with C code, right? You can add more functionality to NumPy using C. And the reason you would use C is because you can actually have faster functions, right? A lot of functionality is written in C and NumPy. You can also integrate with Fortran. I don't know who does Fortran anymore. NumPy is also a hybrid of older packages, NumArray and Numeric, and it replaces both of them. And it replaces both of them more efficiently and faster as well. So again, like it's a third-party package. And now, we remember that line we ran before, import NumPy as NP? Now we're ready to rock. So, how do you use NumPy array? There we go, np.array. You simply take a list and you can just convert it into an array. It's that easy. So what I have here, I have L. All right. So let's say L equals so A, we want to make it a NumPy array. How do I do it? NP dot. Notice when I did the dot, all this stuff pops in. These are all the functionalities there for you in the NumPy library. Massive. A lot of stuff there, guys. A lot of stuff. For us, we're going to use something, this is probably the most common function we use, called array. Right? np.array. And here I simply just give it any list I want. And A now, ladies and gentlemen, will be, so list will stay, the L variable is still a list, it still exists. But now there's something new called A, which is a NumPy array. Notice it's up here, right? And notice a different color green. Spyder makes it, because Spyder's like this is something totally different. But now look at what is going on. First off, notice the type. The type is not list like in L. No. The type is something called int64. Or in some cases, you guys see something like int32, right? What is 6432? That basically is a processor, if you have a 32-bit processor or a 64-bit processor in your computer, right? That's irrelevant. What's really relevant is the int part. Integers. These values are not being stored as list objects. They're being stored as integers. It is very specific to one data type. It's not an object anymore. You can't store anything you want in it. It can only store integers. Why? Because when we created it with integer values, and that's why I kept it as integers. This allows NumPy arrays to be stored much more efficiently, take up much less memory in your computer, and to be processed and worked with much faster than lists, right? Much faster. So, notice the size, by the way. Notice the funky size definition over here. Instead of just having 3, it has parentheses 3, comma, whatever. It's because it's expecting you to have they have a space there for a second dimension. In our cases, it's just a one-dimensional array. That's why we only have 3 values. There's nothing there after the comma. If this was a table, and you'll see that later when we do pandas tables, you'll see that we'll have both rows and columns, right? And there'll be, a value to the left of the comma and to the right, one specifying the rows, one specifying the columns. It doesn't exist yet. So for our array A is just a 1, 2, 3. It's just one size. And that's why it's just going to have 3. And after the comma, there'll be nothing there because it's just 3 elements. All right. Now down here, if I type in A in my console and press enter, notice what I get back. You see, if I type in L, I get the bracket, comma, 1, 2, 3. Not so with A. A is coming, it's coming back with the word array, parenthesis, bracket, 1, 2, 3, close parenthesis. It's explicitly telling you, yeah, this is something totally different here, guys. It's the same list. There's something totally different you're getting back. Completely different kind of data container, right? And it is. Even though it's so simple to create a NumPy array using a list, it's something totally different, totally powerful. All right. For those of you guys that don't have Spyder, if you want to get the size of an array, just do a.shape. Is what we call shape is what we call property, because it's not a function. There's no parentheses, but it works the same way as a method. And when you do a.shape, you get the same thing up here. You have the 3, the comma, the blank, right? And if I wanted just the 3 part, then I would just do a.shape bracket 0. And see, the bracket 0 is basically saying just give me the first element in that tuple. Because notice the values are coming back. The value comes back. What type of object is this, guys? Who remembers? I just said it a few slides ago. This is a tuple. That's right. The shape methodology gives you the answer back as a tuple. In this case, there's only there's an empty tuple and a number tuple. So if I do shape a.shape 0, that's how I get my 3, my length, my actual length of the NumPy array. My actual length of the NumPy array. Okay. Also, dtype is a cool little property as well, and we have that here again in Spyder. But if you're not using Spyder, this is a nifty little thing. If I do a.dtype, well, it's not filling in. A.dtype, I type answer, and here it's giving you the data type. This is integer 64, all right, or integer 32 for some of you guys. All right, we can also create just like we can create lists on the fly, we can create NumPy arrays on the fly, right? So here I'm going to create another NumPy array called B. I'll do B equals np.array. And instead of predefining a list, I just put the bracket syntax directly in the parentheses. And this time I'm going to do something called, I'm going to be a little sneaky here. I'm going to do something 4.0, 5.0, and 6. I type in B, notice the greens, right? But now, notice anything different between A and B? Firstly, this was an int, this is a float. This is an int, this is a float. Also here in the values, you have the values here. Here the values all have dots after them. Even the 6, even though 6 was just a normal integer. What's happening here? A float is a number that is capable of having a decimal place. All right, it's capable of having a decimal place. It does not matter if there's a number there or not. It's the capability of it. Here, when we define B, there was no decimals. It was just literally 0, 0, 0. And 6, we didn't even give it a decimal place, right? It does not matter. Once we introduce that dot, you're telling Python, you're telling NumPy, okay, you want this number to not be an integer, you want it to be a float. Why is that a big deal? Floats, any number that has an integer that has decimal places, it requires more memory to store. It's funky, but it's true, right? So you can have a number 100, that's just an integer, and you can have a number 1.01 that has decimal places. That 1.01, even though it's less than 100, it, in the world of computer memories, for any engineers out there, like computer engineers, that 1.01 requires more memory to store that 1.01 than it does 100. It's wild, but it's true. This is why floats, they have more memory. Because of the fact that for 4.0 and 5.0, the B needs more memory to store them, 6, even though it's an integer, it has no decimal places, automatically gets bumped up to being a decimal place. Why? Because NumPy arrays can only store values of one data type. So it needs to make the call. So it's going to store the values as the largest data type needed for any single value. Because there's a decimal place Just because there's a number in there that requires a decimal, it's going to make the whole NumPy array a float of type float. And that's why it's a type float. And that's why 6 was upgraded from an integer to a float. Right? In most cases, it doesn't really matter, but it does matter when you're doing math between integers and floats, right? Integers and floats. Mistakes can happen. So you have to be cognizant of that. You have to be cognizant of that. For both A and B, if I were to simply say, okay, A1 equals cat, notice you get an error, right? You cannot stick a string now in a NumPy array that is already defined to be an integer. Okay, that's already defined to be an integer. Same thing with B. If I were to do this for B, I would get an error as well. Oh, sorry, lowercase b. Since by the way, uppercase, lowercase matters, guys. So I get an error here as well. All right, I get an error here as well. Now, if I were to do b of 1, what is b right now? So b right now is 4, 5, 6. So if I were to update b of 1 to be, let's say 11, an integer, no problem, no error, right? B will simply have the values 4, 11, 6, and 11 will be just go from an integer to float, no problem. But for A, all right, guys, for A now, oh God, what did I do? Hold on a second, let me fix this. There, I fixed that. But now for A, right? Let's say A of 1. What is my A values, guys? My A values are 1, 2, 3. So let's say for A of 1, 2, I'm going to overwrite to be 11.456. All right? I'm going to execute this. I don't get an error. I do not get an error. 11.456 is a float, type float. A is a data container of integers. I don't get an error, but what does happen? What happens is array A for the second value took the 11. It took the integer value. It did not take the decimal place value. You see that? There is no error. But what it did do is it chopped off the decimal places. It said, listen, I'm an int type of an array. I'll take your integer you're giving me. I can't take your decimal places. I have no memory for them. And it just chops them off. This is a question that majority of you get wrong in the midterm, the first midterm. You'll get right in the second midterm, but the first midterm, you guys will get this question wrong, right? So when you're going from a float to an integer, it'll take the integer, but it won't take the decimal places. So it converts that 11.456 into an 11. It does not matter. If 11 was 0.99999, it's irrelevant. All right? If I had something like this is not about rounding, people. This is simply about memory, right? Boom. A will still simply just take the 11. It does not matter. The decimal places, it cannot handle decimal places. It just chops off any decimal places. Chops off, gets rid of them altogether, and just takes the integer. So that's the interplay between these data types in NumPy array. So this is a level of complexity that's added because of the fact we're dealing with something that's so efficient. So at this point, I'll end. We're already at reaching the hour and 20 minutes mark. So at this point, we are going to end this video because I try to keep my videos at hour and 20 minutes because in a normal school year, our sections are always 1 hour and 20 minutes or 2 sections of hour and 20 minutes with a 20-minute break in between. So I will end this video here and I will pick up the other video. I'll pick up part B for this video for slides 23 to 29, where we're introducing the concept of slicing, or taking a subset of these NumPy arrays. Okay? So I'll see you guys on part B of this video.